All right. Yeah, that's me. Hi, everybody. I want to start by asking, who are you, though? Can you raise your hand if you're an artist or think of yourself as someone who makes art? Cool. How about if you're a designer? It's okay to raise your hand for both. If you make music, all right, my people, cool. All right. And if you've written one line of code, yes! I think this is the only place I've been where almost everyone's raised their hand. Okay, cool. I can use a closer like this. Is that better? Can you hear me better? Cool. Too much? You don't want me to? All right. I'll try and keep it even. So, like Golan said, we kind of hashed this out last night. There's more I have here to talk about than we have time to talk about. So I'm hoping that Golan will help me kind of focus on the things I need to focus on. That's most helpful for you. And I'm also unusually happy in this environment. If you have something that's really prodding you, just raise your hand. And if it's a good time, then I'll, call it out and we can have a little bit more of a dialogue. I've been working with faces for a long time. It actually started on this project with Theo Watson in 2009 called Portrait Machine. We were making these triptychs of people who stood in front of the booth using all kinds of algorithms to analyze people's faces and clothing that were really heuristic. Lots of, test the face detector at different angles, which angle triggers it. Try and take a box that's just above the face detector and use that to estimate what the average color of their hair is. Take a box that is on the y-axis beneath the face detector and use that to estimate some distribution of what colors are in their clothing. And then we did all these funny juxtapositions. Sometimes people would be very similar, sometimes they'd be different. I kept thinking about face tracking, face analysis. I developed face substitution with Arturo Castro in 2011, which is normally it's called face swapping now. And I really love how this technique kind of embedded itself in culture, and I wanted to show one of my favorite face swapping videos. Yeah, basically. Yeah, there's not many regrets I have, but I do think about having patented that. Around that same time, I was thinking a lot about the expressions we make in front of our machines compared to how we make expressions with each other, like in social conversation and interaction. But I live a lot of my social life on my machine, and I felt like maybe I'm missing part of what it means to be me by always have a blank expression on my face. So I did this project where I went to kind of shared public space in New York City where I could take photos of other people legally, called the Apple Store. You can't really do this in other countries, but in America, the legal restrictions around photography are pretty open-ended. And it turned out everyone has the same expression that I felt like this is a kind of lapse of social interaction. This is a completely blank face. Someone described it as the face that you make when you're alone. And I think that's, I don't know if that's the expression that I want to be wearing, especially when the expression on your face impacts your biophysiological system. Everyone knows, if you smile, then certain chemicals are released, but there's all other kinds of chemicals that happen in ways that your face controls your body and vice versa. So I was getting into this. I thought this was like a cool project. I went back and I took the photos and exhibited them in the store with an app that took over all the computers when I pressed a button on my phone. And it just showed a slideshow of everything that I captured over the last few days. I had a lot of fun. I learned a lot, but I felt like it was a huge success, but not Apple so much. At the time, I was living in Brooklyn, and that's my apartment building on the left and the front door for my apartment on the right. Apple actually just called up the United States Secret Service and asked them to follow me on the suspicion that I'd been stealing people's identities. So the day after I posted that video I just showed you, they took these pictures of my apartment, and I eventually got these from FOIA recently. They knocked on my door, they served me a search warrant, and they took my MacBook Pro, which was pretty brutal. And I asked them if they'd seen that video I posted, and they said they hadn't, but I'm retrospect, they probably were just trying to get me to incriminate myself. I suggested they watch it so that they could kind of get like a feeling for what I was trying to do with the project. Yeah, I don't know. The whole experience was pretty traumatic in ways that it took me a long time to figure out. But I just knew I was missing a laptop, so I went back to the Apple store later that day to get a new one. Shortly after that, I mean, this didn't dissuade me from thinking about faces and working with faces. I guess it just reinforced my understanding of how central faces are to all of our interactions with each other and society at large. So I continued thinking about ways of creating other fleeting connections between people. So this piece is called Sharing Faces. It was a co-located installation between Japan and Korea, a little kind of town south of Seoul called Anyang, and kind of city in Japanese countryside called Yamaguchi. And I was working with two kind of groups of friends in both cities. And I wanted to try and break down some of these really intense connections between our face, or the way we appear, and our identity, or who we are. And I guess similar in some ways to Portrait Machine. By having those juxtapositions, you start to have a different understanding of what are the differences between just momentary appearance and like some kind of fundamental identity. I don't think when I made this, I really understood that I was in a kind of position of privilege to even consider what it means to break down that connection. But I did know that it felt right to question, like, why do we judge each other based on the way that we look? And it felt right to create a kind of space for like exploring an alternative world where that connection isn't so necessary. So we made it happen, and it's basically just mirrors your face with faces from people in the other place. And you don't always know at first that they're coming from somewhere else. You just see that there's a mirror of other people kind of responding to you with whatever you give to them. And then later, maybe you'll read the wall text and find out, maybe these are friends from another country. This is another project I was thinking about faces around the same time, where a visitor sits in front of a camera and places their hand on a robotic platform. This is kind of coming back to me recently because it's really intersects with machine learning and AI, which I've been focused on for the last few years. So you hand the visitor a pen, and when they close their eyes, the platform starts moving autonomously. It's a repurposed MakerBot. It is, yeah. And it basically draws a self-portrait that you could never draw with your eyes closed. So we kind of treat the hand or the human body as like a sack of flesh, like a tool for the machine, right? You're like the last little fleshy bit in this big mechanical and computational apparatus. And has anyone, so I studied a little bit of philosophy when I was in undergrad. Has anyone read Sartre or knows about Jean-Paul Sartre? He has this idea about distinguishing between unconscious being and conscious being, where he says that we all feel like really anxious or a lot of angst all the time because we have to constantly be deciding who we want to be, and that's like the fundamental issue with being human. If we could only not have to decide, we'd be a lot more comfortable. If we could be like a stone that just exists without decisions. And I think this piece kind of creates that situation by basically handing our intentionality to this automated system. But if you actually experience it, there's this moment of repulsion of like, as you're sitting down having your hand moved, you're like, wait a second, I don't know if I really want to give up all of my intentionality and all of my ability to like control my free will. You really want to like break free from the system the moment that you feel it. And I think that tension is something I've been feeling a lot working with machine learning, and maybe we're seeing in society more broadly too, as all of these algorithms start to influence our lives in ways that we maybe weren't ready for. This is one I just remembered that I actually, in retrospect, it's perfect, but we didn't talk about last night. So this is a project in collaboration with Lauren McCarthy, who created p5.js, which you might be using. This piece is called How We Act Together, and it focuses on kind of small gestures of social interaction. So when you visit the website, you're asked to perform a really common gesture from social situations. Here, the gesture is greet, and you kind of like hold your hand up and greet someone. While you're performing this gesture, then you see this stream, a video of other people who have performed that same gesture on the website. And we keep asking visitors to repeat these gestures until they're exhausted. So to this point where the gesture starts to feel kind of unfamiliar and the meaning starts to transform, it kind of loses its meaning and becomes something else that's just this weird bodily function. And if you manage to outlast all the other people who have been on the website, then your performance gets appended to the end of the video for that gesture, for others to see. I think this is actually really relevant to this typology machine idea that you're working with right now. We built this in order to collect these videos, but also to kind of get people through this interactive experience to kind of break down what that action or gesture means for them.
I hope you probably remember we also showed Kyle's people staring at the machines project when we were talking about typology machines, right? He's built a machine to collect portraits of people in that certain situation.
Yeah. I had some stuff about faces, but I think I'm just going to skip it because yeah, this is messed up. I don't know if you've seen this paper. This is like who is attractive and who's not according to a machine. Yeah, we'll come back to this if we have time, maybe. There's some interesting stuff in there. So I wanted to share one other project that's kind of from this era called KeyTweeter, which this is my screen in 2009, basically. I didn't really, it's kind of a weird project because it's basically every, do you know what a keylogger is? Okay, so a keylogger is something that you like surreptitiously install on someone else's machine so that you can record every keystroke that they make. And then, you know, you can use to blackmail them or get their password or like surveil someone that, you know, you don't want them to know that you're watching them. I did that to myself. So I installed Keylogger on my own computer. And not just that, I tweeted everything that the keylogger captured for a whole year. So everything that I typed on my keyboard, every 140 characters just got posted to this Twitter account called KeyTweeter. Yeah, sorry, there were 7 exceptions. Social security number, password, date of birth. There's like a few things like that, which I identified as not just information I was producing, but information that would allow someone to become me. And once you can create that distinction, then it becomes really clear, like, what does it mean to sort of live in public versus kind of let your identity dissolve. And yeah, I was really inspired by artists like Te-Ching Hsieh doing these year-long performances that are, yeah, these durational, like really difficult performances. There's everything in here. There's chats with my girlfriend, emails to my parents. My entire master's thesis is actually on Twitter and some of those 40,000 tweets. There's a lot of code. The experience was really intense, and there was a lot of negotiation with other people in my life to try and figure out, you know, when was my privacy starting to blur into their privacy. You know, if my girlfriend asked me at the time to, you know, turn it off while we were having an intense conversation, well, of course I was going to do that, but I guess I wasn't expecting that what I said to someone else was going to be partially owned by both of us. And I learned a lot about some of my own privilege that I hadn't understood before this, about like how I get to live in public, but also some more general things about how all of our privacy works with each other. And this is kind of I guess when we were talking last night, we were thinking about it as kind of self-portraiture, but it becomes something different when it's at scale. If you do self-portraiture over 20 years, or, you know, every keystroke you type for a year, it feels a little different than taking a single snapshot. I just wanted to throw this up here briefly, which was a kind of precursor to KeyTweeter. I was trying to figure out if I could do some visual version, so I made this speed project called Interesting Things, Important Things. Every time I clicked somewhere on my screen, it took a little 32 by 32 pixel icon and saved it to disk. And it shows you like, oh, I like to click on the plus and minus buttons on Google Maps, or this is like me writing code over here.
My students, this is again pertinent to experimental capture in the sense of building an apparatus or an algorithm or a system or machine that, you know, according to a set of rules, captures information for you, right? So Kyle is building a machine to capture what is important, literally what he literally clicks on.
This was around the same time I worked with Theo on a project called Happy Things, which we had the camera running all the time, and whenever you smiled, it took a screenshot of your screen and saved that. And it was an app that we distributed online, and everybody's screenshots got posted to the same website. So it was just this scrolling array of screenshots from different people all over the world. We had to shut it down eventually because it was kind of running in the background, and a lot of people stopped realizing that whenever they smiled, they were being posted to the internet. So we had to take the website down. Cool. I want to talk about a project called Exhausting a Crowd, which was inspired by this experimental French writer named Georges Perec. He wrote this book called An Attempt at Exhausting a Place in Paris in 1974, where he sat on a bench for 3 days and he just tried to transcribe absolutely everything that happened down to the smallest detail as best as he could. So this is a English translation. And for example, he's writing here, a bird settles atop a lamppost. It is noon, gust of wind, a 63 goes by. That's one of the buses. He tried to write like every bus. He was obsessed with the buses. A 96 goes by, an apple green 2CV goes by. I think that's the car, I'm not sure. The rain gets fierce. A lady makes a hat with a plastic bag marked Nicholas. Umbrellas sweep into the church. I like that he's not always sure, like another apple green car, but he's not sure maybe who it is or what kind of car it is. It's intense, and it's like 70 pages or something of just this. It made me feel like, I don't know, one of the lessons here is that it's kind of impossible to avoid categorization when you're looking at the world. Even with all the details that he's put down, there's a ton of things that are lost, right? And what isn't lost, what he has captured, is significantly simplified from like the fullness of reality and our lived experience. So when I was reading this, I was really reminded of this dream of mass surveillance, which is to know everything everywhere at all times, right? But somehow when you read through this, you realize that just knowing things isn't enough. Even when there's more detail to a memory, there's kind of less of a story and less understanding. So I wanted to make a kind of modern version of Exhausting a Place in Paris. And I built this project with a friend, Jonas Yongyan, who helped with the development side. This piece called Exhausting a Crowd. So we recorded 12 hours of a busy intersection in London called Piccadilly Circus. And we streamed it online with a tool that allows people to add notes to the scene. So sometimes it tends towards surveillance. People will leave a note that says like, oh, car runs a red light, right? It's like when you are in the position of seeing things from this perspective, you immediately jump into this mode of like being judgmental and like wanting to say who's good and who's bad. You become like God mode. But most of the time it's kind of surreal or absurd observations. Like I'm actually a black hole sending rubbish to other dimensions where it's properly recycled and reused. This was like a trash can in the middle of the square that is just there for, hours of the video. It's in the middle, and every now and then someone will say something funny like, I'm stuck inside, or R2D2 reporting for duty. This is one of my favorite sequences. It was added really early in the project by a handful of different people. So people would start kind of telling stories together and layering their observations one after another. I'm going to play through and read this. So watch this couple at the bottom right. Oh, by the way, so we've kind of zoomed in to the top left corner. This is like just an excerpt of the piece. There's a bunch of other stuff happening off screen, but I just zoomed in to make it easier to see. Okay, so this couple at the bottom right starts walking in, and so then I says to Mabel, wait, look over there. Kiss me, you fool. Gotta be. What, right here, right now? Yes, kiss me right on the lips. Couple kissing. All of these notes are from different people. Oh, how do I get her back to my flat? Kiss. Do you think anybody's recording us? And then there's this insane amount of detail. Let's see if I can. So he just says, do you think that it's okay to put my hand here? Someone's like, hand placed like a gentleman, hand lower now. This is like a 3x3 pixel region in this 4K video, right? How do you even, the amount of detail in the real world is just staggering. And I think that this, I don't know, I come back to this whenever I see some new company that's like trying to take photos of everybody in the world and do face recognition everywhere, or a company that's trying to build the most surveillance cameras ever, or, you know, solve surveillance or something. I just come back to remembering that more data is not more understanding. Yeah, so this kind of work is on the art side of my practice. I can't survive off of that, even when I get like a generous stipend to come give a talk like this. So a lot of the time I spend consulting. So I don't have a full-time day job or work for any company, but I do a lot of consulting for recurring clients. So Google is one of those recurring clients, and especially Google Creative Lab. So there's a small part of Google based mainly in New York and London, but they have a few other offices where they're basically an ad agency, or like kind of creative studio inside a big tech company. And when you see certain kinds of like marketing from Google, especially if it's like a cool interactive website, it's probably made by Creative Lab. And these were a few projects I worked on over the last few years. One of them at the top left is called Infinite Drum Machine, where we built a kind of new music sequencer and synthesizer that puts similar sounds next to each other and allows you to kind of drag around in kind of sound space to select instruments for a drum kit that you can sequence. The one at the top right, and I can dig into each of these a little bit more. One at the top right is called Bird Sounds, and it's just all of the birds in North America that we have recordings of, kind of organized by sound similarity. At the bottom right, there's a recent project called Pattern Radio, which is 1 year of humpback whale songs, or sorry, 1 year of recordings of underwater recordings that happen to include a lot of humpback whale songs. And then at the bottom left, this was a project called NSynth Super, which is based on, it's like a machine learning synthesizer. So you plug a keyboard into it and you can play it, and it makes really weird machine learning sounds. And I'm going to mention one more to give kind of a different feeling for what this work is like, and then I'll come back to showing a demo of bird sounds and the whale songs. So one of the projects I helped on was called Quick Draw. And I'm going to switch back to my screen for a sec. So if you haven't seen Quick Draw, looks like this. It says draw a sword in under 20 seconds. Okay, here we go. You ready?
I see spoon, or boomerang, or pliers, or wishbone. I see dolphin, or arm. Oh, I know, it's sword.
Great, it got it. We'll do squiggle. That's easy.
Oh, I know, it's squiggle.
Screwdriver. Oh, screwdriver.
I see nose, or spoon, or peanut, or shoe, or marker. I see fork, or frying pan. Oh, I know, it's screwdriver.
Yes! So we successfully moved our fleshy bits around in the way that makes the machine happy. Jonas, who I worked with Exhausting a Crowd on, that was his concept for that project. He works at Creative Lab now. He worked with a team to build that project out, get it rolled out around the world and localized so that people can use it on lots of devices and lots of languages. And from that, this huge data set emerged of, well, let's see, last time I saw it was closing in on 3 billion drawings from around the world. When I got to work with it, it was around 1 billion drawings, and I think something like 100 million of those have actually publicly been released. You can go download them. But I had access to the full billion at the time, and they asked me to kind of think about, what can we learn from this? What kind of patterns can we find in here? Are there any interesting stories? And the first thing we discovered is we did the obvious, just take averages of all the drawings in a specific category or for a specific category in a specific country, right? And we saw this funny thing where when we took the average of the drawings from the US versus Taiwan for the chair category, there's a really clear distinction. So the US draws chairs kind of like from the side, right? And then in Taiwan, they've got this beautiful 3/4 perspective where, I don't know, we still haven't figured out why. Is it like people have better arts education in Taiwan? I'm not sure. But that sort of led us down a kind of big rabbit hole of like, what are all these patterns and how are they kind of culturally distributed? It's a kind of a, like big data naturalism, like looking into these huge data sets and trying to figure out what are the patterns there and what stories can we tell using new techniques for analyzing this data. This was that chair distribution, by the way. It turns out there's this big swath of East Asia and Southeast Asia that has these 3/4 perspective chairs. Let's continue. There's some more examples here. Okay. See if you can you see the difference between the East Asian smileys and the rest of the world? There's like this cute kind of smiling eyes, especially in Korea, compared to pretty much everywhere else. For some reason in like Finland, the eyes kind of look like these wedges, like pizza wedges. I don't know what the story is there. So some of these are unanswered mysteries, like the pizza wedges. Others are really obvious, like these are stop signs around the world, and they look almost all exactly the same because it's written stop in most countries. But here in Israel, it looked a little different. So I dug into it, and it turns out this is what's on the signs in Israel. Isn't that wild? I didn't know. I think it's partially because they have a very multilinguistic group of people there. These are stoplights, and you can see, like, in California, everyone really knows what a stoplight looks like. In Korea, Japan, and Taiwan, it's really common to have these like sideways stoplights, and they're kind of evenly distributed there. Anyway, let's see, what's my favorite here? You might not know that different countries draw snowmen with different numbers of circles. I didn't know that. And when I've spoken to friends in Japan and I tell them that, you know, in America we draw with 3 circles, they're like, that's ridiculous. Yeah, right? But ice cream, like kind of snowy, icy things in general are pretty, you know, there's a lot of confusion and differences over that. So ice cream also has the same thing. There's a kind of 50-50 around the world, like a 3 scoops versus 1 scoop divide. You can even almost estimate average eye color of a place by whether they fill in the eyes, the iris around the pupil or not. So in some countries where the average eye color is darker, you can see the iris is darker, and then like in some countries like Finland, it's very light colored. Different ideas around mountains. You know, is a mountain a single mountain, or is a mountain mountains? Some of those things might have been translation issues. Church, underwear. There's a lot of interesting, here's a good one, bread. There's like at least 3 categories of bread. There's these baguettes, these slices, and these loaves of bread, and everyone has a different idea of what's appropriate. And I think maybe in France they also have these triangle sandwiches that they were thinking of as bread. Anyway, this is part of this kind of more general approach that includes also the whale song. So let me switch to that for a second. I'll show you pattern radio. So for this project, I had access to, I think it was 7 terabytes of compressed audio over about 20-year period that were all recorded by these. Actually, let me pull something else up. Has some better diagrams here. So these recordings come from, oh man. Yeah, one second, I got it. I just need to show what's happening behind the scenes. You get to look behind the curtain for a second here. Okay. Do I accept the terms of use? All right, continuing. Great. So to record these whale songs, like humpback whale songs, they take these huge microphones that are maybe 6 feet long, like somewhere around 2 meters long, and they take a package of a few of them, and then they sync them until they go all the way to the bottom of the ocean, which can be, you know, hundreds of meters. And then they have these kind of balloons that raise up a little bit to bring a line up to the surface that they can kind of come back to and grab and pull it out of the water. Just a bunch of disk drives, batteries, and some hydrophones, which are like oil-coupled microphones, basically. So they deployed these. It takes like 3 months or 4 months for their hard drives to fill up, and then they go back and collect them. And this is the data I was looking at around 2007 through 2017. And I learned a bunch about whales on this project. Basically what they asked me to do, what Google asked me to do, was like look at this data and see, you know, what interesting patterns can you figure out? Like as someone who's doing sound and music and machine learning and art and making interactive stuff and digging into data sets, what's some interesting patterns or stories that we can find here? So I had to start with like a lot of low level, you know, let's analyze these spectrograms, let's clean up these features, let's see if we can extract the whale songs from the audio itself. There's a bunch of weird sounds underwater, try and figure out which ones are whales. Echo sounders. Navy sonar. Was it dolphins? Dolphins. Humpback whale with echoes. Microphone got scratched. Oh, this is a cool sound. Hear that click? That's a whale that hunts by releasing this burst of like stunning sound. That's also a whale at the end that goes. Whang. It's called the boing. It's from a minke whale. Anyway, I had to listen to like probably hundreds of hours of this audio to start to understand what was going on, because it's kind of like learning a new language in a way to listen to underwater sound. It's not like listening to music. And as I dug in, I started to notice that I could pull apart some of these patterns of, when whale songs are repeated. I kind of learned some of the same things researchers already knew, but I like approaching things at first kind of naive, and then once I feel like I've got some of my own foundation, I go back and look at the research, and then I try and bootstrap myself up and learn from all the incredible work that's already been done. But I feel like it's good if you're jumping into this stuff naive. Sometimes you get a new perspective that someone who's been doing it for a few decades might not have thought about, because they've traveled this very clear path to get where they are. So I started to extract these patterns using a mix of computer vision techniques and audio analysis techniques, and see if I can figure out, when is one whale repeating a sound heard from another whale? How are these songs traveling around the Pacific? And it turns out that basically, I didn't discover this, but some other researchers did. It turns out humpback whales will all go to the north around Alaska in the winter, and they'll sort of do like jazz with each other. They'll just kind of like improvise, let's try some different songs out. But then before the winter's over, they'll settle on one song that they're like, that was the dopest hit this winter. And then they'll just sing it for the rest of the year. They'll all sing it, and that's their song. Like, they do small variations on it to kind of show off, like, look at me, like, I know how to improv on that one. But they'll all sing the same song, and then the next year they'll do it again. And they've been doing this, humpback whales have been around for a few million years, and they don't repeat songs. So as far as we know, we haven't heard them like take a song from like 20 years ago and do it again. So we don't know if there's some larger cycle that we haven't heard yet, but yeah, it's kind of mind-blowing. The other really scary thing is we almost hunted them to extinction in like the 70s. It was really close to them just disappearing completely. There's other whales that are still endangered, but humpback whales are doing okay now. And it's kind of, it's like almost too much to think of like this amazing culture that's been around for millions of years that we don't understand almost disappearing completely. So anyway, I did that research, and then Google jumped in and took all the data that I was able to extract, and kind of took part of it that they liked the most, which was this idea of kind of sonic similarity, and they built that into this interface. So on this website, you can explore about a year of the data. And if you zoom in, you can start to see, here's a sound. You can start to see some similarity. As your kind of cursor is highlighting each of these sounds, you'll see the other sounds that are similar. And you can also zoom out more and start to see larger patterns that are just based on kind of spectral long-term averages. Yeah, let's find something interesting. Maybe somewhere around here. This looks noisy. Oh, so this is like the ocean is completely full of engines. A lot of the times the whales can't hear each other very well. So that's just like a boat spinning up nearby, and it's in the exact same range as the whale songs. Let's see if we can find another one. This looks very red, so it's probably got some whales here. Yep. So I can actually, I've looked at this enough that I can see some of these patterns, these kind of falling patterns right here. These are whale songs. All of this is whale songs. So they have larger structures. They sing songs for about 20 minutes, and then they go back up to the surface and then go back down and sing the song again. They're good. Yeah, Google really took this to like the next level by making these tours on this website, so you can, check out what a composer thinks about these, or a philosopher, or a 7th grade class. Yeah, I talked a lot with this guy Matt Harvey, who's a engineer, but he's also like bioacoustics researcher. And one thing I was really happy with about that project is that the work I did on that eventually made its way into like some real bioacoustics research. So even if everything I do doesn't always end up on a website or in some interactive experience, sometimes it turns into one of my future projects, or I can share it in some other way where it turns into some scientists' work sometimes. I'm going to continue, and we could, actually I'll do a quick bird sounds just for fun. This was like a 1-day speed project for me to make the prototype of this, and then they spent lots of time building a website around it and iterating on the UI. And so it's loading 14,000 bird sounds.
Something that we'll be seeing later in the semester, my students will be looking at data sets of various things, images or other kinds of data, looking at ways to analyze them spatially. That's kind of what we're seeing here.
Yeah, so the idea here was, so the first step is you got to take all these long recordings of birds and chop them up into sort of units or individual sounds, like, or, but then you've got to organize them somehow so that it makes sense, because there's a lot of variety to these sounds. Let's just poke around. There's a lot going on. So if we want to kind of navigate them, one way to navigate them would be by putting similar sounds close together, and then we can just kind of Who knows how to beatbox? Yeah, and the technique we used for organizing these was something called T-SNE, which is spelled like this, T-SNE. This has been one of the best algorithms for doing kind of similarity-based organization of big data sets for a long time, but it was just recently displaced by another one called UMAP, U-M-A-P. And basically what those algorithms do is they literally take a grid of numbers where each row is a data point and each column is a value, like a different dimension. Maybe it's, if you're talking about flowers, it would be like the petal size, the petal color, the petal width, the petal length, how high you found it off the ground, whether it's decomposing or not, everything that you could use to describe a thing. And then each of the rows is like one thing, right? In this case, each row is one bird sound. And then each column turns out to be, let's say it's like how strong a specific frequency is, whether it's a lower frequency or higher frequency, what combinations of those. So TSNE and UMAP, they'll take that grid and they'll convert it into a grid that has fewer dimensions. So instead of 100 frequencies, it'll give you 2 dimensions. And those 2 dimensions you can plot in like a 2-dimensional space so that those things that are similar to each other end up close together, and the things that are dissimilar end up far apart. It might sound a little abstract at first. If you see like some visualizations of how it works that I'm sure you'll run into later in the semester, it'll be a little more clear. But that's the basic technique for how it's kind of infinite drum machine and bird sounds, and even to some extent the whale songs project used some of that. All right, we're going to talk about bodies. We've got 15 minutes left. Yeah, this will be good. Okay. So you've probably been using or thinking about or seeing some people do ML stuff. There's a lot of ML out there for analyzing and understanding bodies. It's kind of like a golden age in some way. We just since maybe 2010 with the Connect, it's the first time that people in media arts have really been able to understand bodies at a distance in the same way, in a similar way to humans or a choreographer or a kid might describe a body, having joints in certain places, having certain orientation of your limbs, this kind of thing, having an outline against a background. I've been working with this tech in the context of dance for a while, and I started with more kind of traditional computer vision techniques. This was a piece with Daito Manabe and Klaus Obermeier that we showed at Resonate Festival, part of a longer performance. But a couple years ago, Daito, who's a media artist based in Tokyo, who runs a company called Rhizomatics, he asked me if I'd be interested in working with him and his partner Mikiko, who is a choreographer for a group called 11 Play. She's a very renowned choreographer. She's also, if you know Japanese bands like Baby Metal or Perfume, she choreographs all of their dance. She did the closing ceremony for the last Olympics. Daito asked if I'd be interested in working with them on a new project that kind of connects machine learning to dance through a longer history of kind of computation and numbers and the body. And he showed me some examples of how different indigenous people around the world have used bodies for arithmetic over time. So this is from the Oksapin people in Papua New Guinea. Instead of counting, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, they will use many more joints. So they'll start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and they visualize this kind of succession of numbers happening across their body. There's other people who will be able to do arithmetic like in that space, so go back and forwards in there, or even do kinds of multiplication. And that's been happening since prehistory. But recently we have kind of new perspectives on what bodies look like through the lens of mathematics or computation. Even Alan Turing was thinking about computers as kind of an extension of human flesh. But these more modern techniques are normally just for the purpose of surveillance. We're trying to track people so that we can kind of control and analyze them. This is some research from Facebook for a project called Dense Pose, where instead of just tracking individual joints, they actually have entire kind of mesh that they use to wrap the image of a human body. But we were looking at, we were trying to understand how this is going to make sense in how is this was going to make sense in the context of choreography. We didn't just want to analyze someone's body or tell them what to do. We wanted to get something more like a kind of alien perspective, a machine perspective on human movement. We were inspired by this work from Luca and Luis Chernovic-Fries, where they collected 5 hours of data from a single contemporary dancer, and then they processed that data with a neural network called an LSTM. It's a kind of recurrent neural network, or RNN. And that means it's designed for processing sequential data instead of like an image, which is like everything at once. It processes steps of data. So this pose, this pose, this pose. And they use this to do some very simple tasks like let's try and classify what category of dance this is, or let's try and generate a few more frames that continues the current dance that we've captured. This is like another example of using an RNN to do that kind of classification or generation task. So this was a project from David Ha called Sketch RNN, where it trained on that quick draw data that I talked about earlier. You can start drawing like a mosquito, and it will continue drawing a mosquito based on what it thinks the process is like for drawing mosquitoes. So we basically follow this same process. We collected about 3 hours of data with a motion capture system called a Vicon mocap system. We gave the dancers a beat, really minimal beat, and then some prompt. So Mikiko came up with some prompts like, do the robot, or be sad, or act cute. Very simple, something that gave them a lot of freedom to explore like a feeling usually. And then on the right you can see, so on the left you can see us recording the data like in the studio, and then on the right these are all the recordings of the data that we collected. This ends up in these files called BVH files, which are kind of motion capture system. But we constantly, like, I don't know, as you're doing machine learning, you learn really quickly. You can't just do machine learning on the same kind of file formats and representations that people have been using for years to do that kind of thing, whether it's dance or whether it's music or whatever. You usually have to convert it to some other kind of representation that makes more sense for a neural network to process. And in this case, it puts you directly in in the face of deeper ontological questions about like, well, what is dance really? What are we talking about? Are we just talking about the movement of limbs? Does it matter where the dancer is in the space? Does it matter in this case or maybe not in this case? So we had to start reconfiguring a lot of that data to something that would make more sense for our application. Tried a lot of things like neural nets that would compress a single pose. So the data on the left was the input and the data on the right was the output from the network, and it sort of regresses everything towards the mean. So it can't really copy what's on the left. It's sort of like a slightly drunk version where it's like, yeah, kick. But in the end, we used a really unusual representation called Quaternions with a sequence-to-sequence network, and we managed to process all this pose data over time. There's glitches, at first it's like you make one error in your Quaternion implementation, and it's like suddenly you have the scariest thing you've ever seen. But then eventually, after everything trained correctly, we let it train for a few days. We started to get output that looked more similar to our input data. The biggest difference across all these experiments is that the hips, we had to fix them in place as a limitation of our representation, which means that the dancer kind of looks like it's flailing around on a bicycle seat. And we're still working on that as a kind of technical limitation, but because this is part of a kind of our practice, we are also investigating each of those glitches for their sort of suggestive potential. And has anyone trained a neural network before? A couple people? Okay, so you might have seen this thing called a loss curve, which tells you, which sounds really poetic, but it tells you how well the neural network is learning to do the thing that you asked it to do. Usually what researchers do is they wait until it goes to close to 0, and then they say, oh, okay, I'm done. Like, it learned, like it's making very few errors. Or the inverse of that is the accuracy curve, right? So as it gets close to 100% or 1.0, you say, okay, it's pretty close to being done. We decided to basically stop it really early in the process because we noticed that before it started to converge on really knowing what dance was, it was producing these really weird, not quite human movements that were somewhere in between like human movement and machine understanding. And that's exactly what we were excited about. So at the beginning of this scene, Maru, who's the real dancer from a Levin play, she starts kind of exploring this space around this AI dancer and kind of keeping her distance with this mixture of like curiosity and some suspicion. But eventually she tries to imitate the dancer. Oh, we skipped it. And I think that was one of the most exciting moments when she like tries to do this flailing, because it represents this really long process from all the way recording the data, training the neural network, putting it into this generative 3D body, and then now back into a human, right? It feels like really representative of some of these things I was talking about earlier, like all these algorithms in our society that we don't really understand how they're impacting us, or we're just starting to understand. Then we do some interpolation to kind of make this mixture between the original choreography and the generated dance to have this slowly evolving duet. There's a bunch of other stuff happening in the performance. I hope you all get a chance to see it sometime. There's like a debug scene where we show everything that went into the training process, and it's got like a heavy techno beat. It's more like juke, I guess. It's totally over the top, but it's like the one chance in the performance that the dancers get a chance to rest for like 20 seconds. I'll keep coming back to these point clouds. This is again UMAP, so we're doing instead of projecting with UMAP to 2D, we're projecting to 3D, which means that each of these points is one pose. That's one data point, and we're taking all of the choreography and we're kind of creating a path through space, so that when it returns back to some pose that it's been through before, then the path comes back to that same spot. I'm going to continue for now. Oh, we also did this fun thing where we recorded kind of donated dances from visitors to the piece just before the doors open. So in like the 15 minutes before the doors open, we have this little kind of miniature stage outside that's set up where people can try and imitate the choreography themselves. And then we ran it through this system called Pix2Pix HD to generate sort of fake dances for everybody. It's very similar to a paper that came out around the same time called Everybody Dance Now, which is here. And then we bring them into the performance where, I don't have a video of this, but we basically show them dancing the choreography in this really like blob-like way where it starts to become clear, oh, that was me, those are my clothes, like I can almost see my face. This is, again, like halfway through the training process. Pix2Pix HD normally takes like 2 days to train, but we did something weird here because we only had 15 minutes between the doors opening and the show starting to train it on like a huge cluster of AWS machines, get the results back, and then take them on a USB stick and toss them to the guy who's running the visuals. That was scary. Okay, last body thought. OpenFitlab with Lisa Corey-Chung. This is, in terms of like the kind of technical side of capturing bodies, this is a lot simpler in a way. We basically threw a party and we wanted to make jeans for everybody that fit them, because jeans don't always fit great, So we got everyone to wear these green spandex pants, put them in front of a Connect, and then automatically took measurements, like pretty dense measurements of the size of their legs over the entire height of both their legs. And then we fed that into a pattern generating program that Lisa wrote. And we had this kind of assembly line of seamstresses that would kind of do some mixture of their own interpretation and following the machine's directions to produce, in the end, I think we got like 6 jeans made over 2 hours, which is pretty quick if you've ever tried to make jeans before. The first ones were like, something's a little wrong here. And we weren't quite sure what was going on. So we told everyone, like, stop the presses. We've got to figure out where the error is in our pipeline. Like, we need to debug this. And so we walked back one step at a time. You know, the seamstress following directions. She's following directions, following directions. Good, good, good. And the Connect's working correctly. So it's something between the Connect and the cutting. What could it be? What could it be? And we noticed the projector that we were using to project the patterns onto the denim, someone bumped into it. So now all the patterns were like 2 sizes too big because the projector wasn't calibrated to the right dimensions anymore. Anyway, I'm really excited about these kinds of projects where it's not just taking, you know, some new tool and doing the most impressive technical demo, but it's more like, you know, let's build some kind of democratized, community-oriented tool that helps us explore some idea together. What would we do with this thing if we could really quickly measure people's bodies? What if we, you know, what if we're making tools that help account for all the differences between people instead of trying to make everyone the same? Okay, I was going to mention some tools, but actually sort of wrapping up here. Maybe I'll just say these quickly. There's some tools I've been using recently. Who knows Runway ML? Okay, cool. Check this out if you haven't already. Cool, great. ML agents in Unity if you want to train like reinforcement learning agents to like do funny things in 3D. Probably all know Dan Schiffman, hopefully. If you don't, he's the bomb. There's a bunch of APIs out there if you want to do some of the weirder stuff that you don't want to implement from scratch. You can always go ask Microsoft or Google to do it for you, and they've trained plenty of algorithms that you can use for good. It doesn't matter what they're using them for, put them to work for good. There's a lot of stuff there that in those APIs that just hasn't been used as well. Like Google has a really incredible handwriting detector and kind of decoder, like handwriting transcription. I've never seen anyone use it for anything interesting, and it's just waiting there to be used for something. I use Jupyter and Colab a lot for doing, like I mostly write Python these days. I used to write a lot more OpenFrameworks, and I spend a lot more time on the data analysis and processing side than I do on the presentation side recently. Scikit-learn is fun for the ML stuff. dlib is great for face analysis and recognition. Here I was trying to figure out who is the most, in any photo, who is the person that doesn't belong? Who's the person that looks least similar to everybody else? And it turns out it picked this one lady over here that's like just to the right of Trump. And I found this photo because I thought, oh, this is funny. This is like a super homogenous room of white dudes. And then I looked into it when I was like, oh, I wonder what the story is here. Why is she there? And it turns out it was like something about some legislation around abortion. And I was like, oh, yeah, of course it makes sense. It's all men in the room. Yeah, okay. That's how we police women's bodies. I'm working with Librosa a lot for sound, which is like if I'm doing anything with the whale songs or with Infinite Drum Machine or the bird sounds, this is like my starting point. Everything I do with audio starts with Librosa pretty much. TensorFlow and Keras and PyTorch, these are like the deep learning toolkits. If you want to get really low level, once you've figured out how to use Runway ML, that's a good place to start. Archive is one of the best and most underused tools in this list. This is like all of the machine learning research out there. It goes onto this website. Everyone publishes there. It can be a little opaque sometimes, so you might want to check out Papers with Code, where there's some folks who combine papers that have been posted to arXiv about the latest machine learning research with some new GitHub repos where there's actual implementations of the thing that you want to try. It's also, both of these are like a good place to track, you know, what are the kind of dangerous things that are sort of society changing that are happening right now. You know, you can find papers about Chinese researchers trying to identify Uyghurs based on face recognition algorithms. And yeah, it's a pretty good place for just keeping tabs on the pulse of machine learning. Okay, last project. Oh, thank you. Yes. Two more things. I'll keep it. Yeah. Yeah, exactly. Okay, so I've also been working with Rhizomatics on another project. I'm going to put this on loop. So Rhizomatics are like experts when it comes to motion capture, 3D scanning, augmented reality, VR, drones, like everything that's like a buzzword, they have mastered it. And they're always looking to like, how can we push all this tech in a direction that's actually interesting instead of just impressive? And for this project, they brought me on to help with some kind of tracking that reaches slightly beyond what they are comfortable with. So they wanted to do augmented reality over fencing in real time in preparation for the Olympics this year, which we'll see if it shows up at the Olympics, but we've had a chance to do this a couple times now at the World Cup a few months ago, and there was a smaller like All Japan Cup where it's just a bunch of like the best fencers in Japan coming together. Usually, when you're solving this kind of problem, you would modify the environment somehow. You'd put some special tape on the blade, you'd like sand something down, you'd put a marker somewhere, you would change the lighting somehow. Like none of this is allowed in Olympic level athletics, right?
It's the big difference from media arts. That
Yeah.
points out in media arts, if you want to track something like, oh yeah, stick a retro reflector on it, or oh, we can have a nice black background to this installation. What you're about to see is like literally like just at the bleeding edge of what's possible in a situation with profound constraints about what Kyle and his collaborators were allowed to do, because you cannot tinker with, you know, the fencer's blades and the environment that they're in.
Yeah, they should basically not know that they're being tracked. It should be zero difference for them. Anything psychologically or physically modified about the space is like just totally off limits. So this is somewhere closer. I don't know. It's a different intersection of like arts and engineering than I'm used to, because it has really, like Golan said, a kind of just profound constraints. And we started with, actually Rhizomatics started with a very simple system before I even got involved, which was just based on taking a single camera view and using like a object detector to identify the tip of the swords, or weapons as they call them in fencing. And from a single camera, you can like do a single 2D overlay and it looks kind of cool. You got these like ribbons trailing. But what we wanted to do was something that was really 3D, something that really understood not just what they looked like from one perspective, but you could see from above, from the side, from behind, and even have another camera in the space, like someone with a handheld camera that we were tracking, where we could do overlay on top of that. Even though we weren't doing machine learning or like doing analysis of that video, we would still be able to figure out what's the correct overlay for that video.
My current capture students is like, how can we know everything about the geometry of the fencer and their weapon, you know, as quickly as possible and at the highest resolution and accuracy?
Yeah, and so I can share, unfortunately I can't share everything about this, but I can share a few things. So we used 20 cameras that are 4K 60 frames per second cameras. That's a lot of bandwidth, and it's all going back to a couple machines that are kind of processing which videos to like they're picking which streams to use based on some LiDAR that's set up in the space. So the LiDAR is helping us determine, out of the whole piece where we have a bunch of cameras looking at each section, which section should we be looking at and analyzing right now? And this is all stuff that you can see when you're in this space. That's not hidden. You can see the LiDAR, you can see all the cameras. And I'll show actually one behind the scenes video that I got permission to show. So we couldn't have fencers all the time, right? What's that? Oh. Oh, wow. It was black even when I was just talking now, too. Oh, wow. Okay. Great. All right. Wow, you've been listening very closely to nothing on the screen. Thank you. Da 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 da. Damn it. Okay. I don't know how to use computers, Golan. All right. Da 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 da. So this is 3D, and you'll see a little more clearly that it's in 3D in a second. It's in real time, so we have a long delay to make sure that the system's kind of maximally optimized to not drop any frames. It's about 2-second delay, but basically that means we can be watching the fencers on the piece, and then right when a point is scored, we can kind of look at our system and see it start to process the video, and then see the render out. We can follow it with our eyes, and it's pretty neat. So I'm just gonna play this a couple times while I'm talking a little more. Yeah, so one of the, there's a lot going on. A lot of my work was divided into 2 parts. One was the training the network to do more accurate tracking of the sword tips and sword bases. And then another big part was the engineering task of like, how do you process 4K video at 60 FPS from many streams on a fixed number of computers efficiently in real time? Sometimes, so like I think of myself as an artist, but I do have like an engineering background and CS education. And sometimes when I get really deep into these like technical issues, I have like this kind of identity crisis where I'm like, oh, this is so much easier than art. Am I really an engineer? And then I get really kind of stuck on some aesthetic or artistic or conceptual details of it. And then I remember like, well, if I was an engineer, I probably wouldn't be as stuck on those things. And it's okay to be both. Like, it's not that you have to just be one or the other. I think sometimes when I feel like my art's not very good, then I get like more in that mode of like, well, maybe I should just focus on the technical sides, but that's a trap. Like, I think you gotta always be pushing hard on both aspects, like the craft of your work and the kind of concept and the aesthetics of your work, or it's just not gonna be interesting. You gotta put all of yourself into it. So I'm trying to do a little bit of that with this, but I am really involved in more of a technical capacity on this project. I've been advising on the way that the visuals look, but I haven't been implementing them. So there's one other video I wanted to show of this. When we do testing for this, you can't just have fencers around the studio all the time. I mean, well, I guess you could, but not the level of fencers that we need to be working with. And that amount of space in Tokyo is really hard to find. So we built this. It's about 2 meters long, and we have all the cameras like right next to each other. So they're in the exact same positions that they would be, but scaled down from the whole venue. This is the interface for capturing all of the video feeds. So that's all 20, what's that, 20? 1, 2. That's more. It's complicated, and they're not plugged into one computer, but they all end up on one computer. Yeah. So I guess that was 24 maybe. So I think we used 20 in practice, but during development we were using 24 for completeness. And then we've got these little models that you could see. So this is, we do a kind of multi-scale approach where we first figure out where the fencers are, and then we kind of focus in on their swords. There's a lot of tricks that I did around like if you look really closely, you can see there's like this little line coming out of that green circle. So I had to not only figure out using like 3D geometry where in space is each of these things, but also what direction in space are these things pointing. Because a fencing weapon isn't just like a straight line. It goes like this. It's actually a little bit more like a whip. It's just a really hard whip. And then there's this other system where you're seeing like all of the frames being processed across the multiple machines that are doing the processing and the like LiDAR data from the LiDAR rangefinders. Like lots of debug stuff, how much GPU use is happening across all these computers. More processing. You're only looking at half the cameras right now. The other half are mounted above, looking down. And then this is like the final visualization pass where we just go over here and da-da-dum, that's what we get. Everything for those two bendy lines. Yeah, anyway, it's a really big, complicated project I hope to talk about more soon, but it's really opening my eyes in some ways to like how some of the things that I've been learning from just basically making interactive art with computer vision can be applied to other domains. I mean, I guess the whole working with Google thing has been, it's not what I would like to continue doing. I like to be getting more public funding and survive mainly off my artwork and my art practice, but I'm starting to become more open to like all these other endeavors of humanity, like sports. Sports are pretty great compared to advertising. Sports are awesome. Yeah, wrap it up there. Yep, thanks. Thank you.